Hi, this is Alex from devstories.eu. LangGraph, Episode 1 of 18. Most large language model scripts work perfectly for a quick prompt and a fast response, but when a task takes 20 minutes to run and the network drops halfway through, everything falls apart. You lose your progress, your context, and your API budget. The orchestration problem, why LangGraph, is exactly about fixing this fragility. LangGraph is an orchestration framework built to handle stateful, multi-actor applications. You might hear the name and assume it is just a feature of LangChain. It is not. LangGraph is a lower-level orchestration engine, and you do not need to use LangChain at all to use it. It exists specifically to model agent workflows as stateful graphs rather than simple linear scripts. Standard scripts execute in memory. If a script stops unexpectedly, all that runtime data vanishes. Consider a scenario where you have a background agent researching a 100-page document. The agent has been reading, extracting facts, and cross-referencing information for 20 uninterrupted minutes. If a server timeout occurs at minute 19, a standard script drops all of that state. You have to start the entire job over. LangGraph solves this orchestration problem through durable execution. By modeling your workflow as a graph, every distinct step becomes a node, and the logical connections between them are edges. As the application moves from one node to the next, LangGraph automatically saves its progress. It treats long-running processes as a series of safe checkpoints. If the system crashes, LangGraph resumes execution exactly where it left off. This checkpointing mechanism relies on comprehensive memory. Memory in LangGraph is not just a running list of chat messages, it is the entire state of the graph. When a node finishes its processing, it updates a shared state object. The next node in the sequence reads its input directly from that state. This means memory persists across the entire lifecycle of the application. The background agent researching your document doesn't forget the critical data it found on page 5 when it finally reaches page 90, because the graph state holds onto it securely. Here's the key insight. Because the graph state is paused and saved cleanly between steps, you gain the ability to put a human in the loop. Sometimes an autonomous agent reaches a decision point where it needs permission before proceeding, like sending a final email or executing a financial transaction. In a standard script, pausing for a user to click a button often leads to connection timeouts. In LangGraph, you simply configure a specific node to halt execution. The system goes to sleep and preserves the current state perfectly. A human operator can then review the gathered data, approve the next action, or even manually modify the agent's state before hitting continue. Once approved, the graph wakes up and resumes its work with the updated context. The core takeaway is that building complex agents relies heavily on managing state and failure. LangGraph shifts your architecture away from brittle memory-bound scripts and toward resilient graphs that survive interruptions, remember their past, and wait patiently for human guidance. If you would like to help support the show, you can search for DevStories EU on Patreon. That's all for this one. Thanks for listening, and keep building.